You are listening to EETimes On Air, and this is EETimes Current. I'm Eric Singer. Today's episode is brought to you by Siemens EDA. Carrie Robertson is Vice President of Product Management for Siemens EDA and oversees the product development for Calibre design-side products. He's been with Mentor Graphics and Siemens EDA for 27 years in various product management and engineering roles. Prior to Siemens EDA, Carrie was a design engineer at Digital Equipment Corporation working on microprocessor design. Carrie holds a Bachelor of Science degree from Stanford University and a Master of Science from UC Berkeley. Today, we're going to be discussing Siemens EDA approach to AI, and then we'll dive into some Calibre-specific topics that I know are going to be of interest to our audience. We'll talk about when to use it and when not to use it. We're going to focus on productivity and practical things like maximizing designers' effectiveness without compromising any quality. AI is being used in everything these days, from space exploration to dating apps. Siemens has obviously notably invested heavily in AI for quite some time, long before it was a trend. So let's get into it. Carrie, thank you so much for joining us today.
Thanks for having me, Eric. Happy to be here.
Talk to us a little bit in broad strokes about how Siemens has been approaching AI and what the overall strategy is.
Certainly. Thanks for the question, Eric. From a Siemens EDA perspective, we've been looking at AI for some time. As you mentioned, AI permeates nearly everything that we're doing now. And in our work environment, and as customers look at semiconductor design, that is certainly a necessary and useful tool. For Siemens EDA, we've been investing in this for upwards of 10 years now. And it started with acquisition of Solido some years ago. But amongst all the product areas, we've been investing in AI and working to leverage that technology, that capability throughout all of our products. And we discussed it at DAC, a complete Siemens EDA AI system that is the platform that all of our products are able to use. And it's what we want to spend a little bit of time talking about that today.
That's great. And then specifically talking about design and verification, can you talk to us a little bit about how Calibre is leveraging AI?
Yeah. Eric, to introduce Siemens EDA to the design community here, what we have in place is, first off, a common set of AI models, LLMs, agents, capabilities that will be leveraged by all of the Siemens EDA products. So that's kind of the starting point of our capability. Along with that, it's not just AI models and AI agents, but it's also a complete data lake where customers can put design data, they can put best practices, they can put documentation, their own IP. That really makes this platform extremely powerful and extremely customizable to the customer and to the designer. And then the final really key capability is that it's intended to be open. Yes, Siemens EDA tools will interact with this along with the customer's data, but we will also make this an open environment where, as customers want to bring in their own scripts, third-party EDA tools, it can be comprehensive in storing their design databases, their design histories, to be as functional and as accessible as possible. And we'll talk more specifically about that as we discuss how Calibre is going to use that, but we have a common starting point across all of the Siemens EDA tools.
Yeah, I've always been impressed by the comprehensive vision that Siemens has on this. And so let's dive into Calibre a little more. So moving beyond LLMs and agents, talking about testing and verification, what are you doing on the Calibre side of things that's leveraging AI?
This is a question we get asked all the time. And it's typically, well, how is Calibre DRC leveraging AI to do verification? And our response is in core Calibre algorithms, where you're counting on us to verify your design and to make sure that it is going to be sign-off ready and you're going to have good, successful silicon at first pass. We're using very little, if any, AI during that process. We continue to use completely deterministic algorithms to identify whether your design is DRC clean, LVS clean, and all of the other verification tasks you expect Calibre to do for you. So we continue to rely very heavily on deterministic algorithms to get to sign off. And the reason is very simple. You want the same result over and over again. We cannot tolerate a potential hallucination during that computation. So the core Calibre capability of determining sign-off quality is and remains highly deterministic. Now, that being said, there are a lot of steps to get from a design to final sign-off in the space of DRC, LVS, electrical reliability. A lot of steps to make that happen, and we are using AI techniques throughout that to help designers get to sign off as quick as possible.
That speed is certainly the name of the game these days. Timelines and delivery schedules have gotten shorter and shorter. Designers are, of course, under increasing pressure to get things ready for market as quickly as possible. Can you give us some examples of what you're doing in the real world today on the design side?
Yes, a number of phases or a number of areas that we're investing in. The first is in just setting up the tool. As you look at the various workloads throughout the verification process, they are not very homogeneous. There's a variety of different things that you need to do. They require different complexities in your compute environment, whether that's on-premise resources or using the cloud or some hybrid. We provide a number of techniques to identify what is the most efficient use of your hardware resources to get a particular verification task done. So that's where we start, is helping you to set up a particular Calibre run and leverage what hardware resources you have available to you to get this job done as quickly and efficiently as possible. The second step is then understanding those results and debugging those results. What we've heard from customers is it could take 2 weeks, 4 weeks, 8 weeks to get from that initial GDS to a DRC, LVS, electrically reliable design. And in that interim of having that first pass at the full chip design, you're doing a lot of debug. And that's where AI techniques are extremely useful to help you determine what you should be debugging first, second, and third. Sifting through the variety of errors that can come at a particular designer is extremely daunting. And we have techniques that can help organize the data and help you prioritize how you use your debug time most efficiently and reduce the cycle time of that overall verification task.
Yeah, obviously, incredibly time consuming to go through debug reports, especially in early stages as you're just getting things together. Are there any customer examples that you can give us to make this even more concrete?
Yes, we do have customer examples. At DAC, we announced a product called Calibre Vision AI. And in the evaluation of Calibre Vision AI, we worked with a leading GPU manufacturer. They were taping out a design, and when they initially ran their first full chip run, they saw literally millions of errors. As they took a look at those millions of errors, they had techniques. These is a sophisticated customer, and they had techniques in terms of how to organize that data, how to properly assign that to various people. But with Calibre Vision AI, we brought to them 3 primary capabilities. The first is being able to view a full chip design along with those millions of errors.
Mhm.
This is not something you can do in a traditional viewer. The ability to pan, to zoom, to look at different aspects of the chip. It takes a long time in using traditional methods to be able to view that and to zoom in. So Vision AI, number one, brought in significant advancement in visualization capabilities. The next piece, which brings in the AI component, is being able to organize those millions of errors into something that is consumable. Back when I did design, if I came across millions of errors, I'd probably just click that window away and wait for the block owners to do a better job. What this company wants to do is they want to organize this and set this up into particular groups. We call them signals. So the AI component of Vision AI is to organize these millions of errors into common areas or potentially even the same common root causes.
Hmm.
And we're able to organize those millions of errors into tens of what we call signals. So that in and of itself is a huge productivity gain. But then the last component is nobody is debugging a full chip problem on their own. Now, there may be an individual designer who ran that DRC job and then opened it up initially to see these millions of errors, but what they need to do is assign those errors or groups of errors to various owners, a block owner, a chiplet owner, an expert in a particular aspect of this design. So the final portion of this is using a technique that we use in our social applications all the time, consumer applications, which is we bookmark it. And so a single designer can now start to assign groups of errors to individual owners and improve their productivity. Whereas previously they're using Excel spreadsheets, using HTML reports. This can all be done in the tool. And as those assignments are made, an individual owner can bring up Vision AI and go directly to what was assigned to them. So the net result of this story is they estimated that they shrunk that verification time by 50%.
Wow.
And when you're talking about 4 weeks, 8 weeks in terms of time to get to silicon, that's a significant opportunity,
Yeah.
significant ROI in terms of getting your silicon to your foundry in a reduced amount of time. That was significant.
No doubt. So obviously, absolutely massive return on investment, as you say, and dramatically decreased wait time for hitting silicon, and just a tremendous amount of savings in person hours. Are there other Calibre applications that you can share with us?
Absolutely. And as you look across our productivity tools, we're leveraging AI techniques in virtually all of them. A few that I think are important to mention. Back to this overall notion of productivity and how do we debug things as fast as possible. We have brought out new capabilities in RVE, Calibre RVE, which is our results viewing environment that is called Check Assist. What we're finding with many customers is that yes, we can find the DRC errors, but identifying the root cause and determining how to fix it is very, very challenging. And it only gets harder as nodes get more advanced, as manufacturing techniques become more complex. A designer could look at, say, a DRC error in a spacing check, and other than knowing that's an error, may not know, well, why is it an error? And potentially, if they don't know why it's an error, they may not know how to fix it. So the check assist capability goes back to either Foundry design rule manuals or best practices within the given company about what drove that to be an error. And so it's essentially advanced documentation and advanced isolation of that root cause to help the designer determine, okay, here's the nature of the error, and by understanding that, they can make a better use of their time in terms of how to debug it and how to fix it.
What strikes me about that as particularly interesting is that it's not just increasing the productivity, but this is a great learning opportunity for the designer as well to have that larger contextual understanding of why these errors occurred.
Absolutely. Great learning opportunity and great way to bring more junior designers up to speed. So instead of a senior designer walking the hallways and help educate designers, which is nearly impossible now because we work in a worldwide environment and you have design teams in various regions and various time zones, and experts are not accessible in the office and they're not accessible 24/7. but a junior designer can bring up an assistant and get some education in terms of what is the root cause of this error and how to quickly fix something.
I love that so much because so often AI is used in ways that, for lack of a better term, are, well, let's say they're not making us smarter, right? They're shortcuts so often, but this is actually providing not only the solution, but making us smarter as we use it. We're not just training the model, we're training ourselves.
Absolutely. It is on the job training and it makes accessible advanced information very easy. It's at your fingertips. You could go read the manuals yourselves, you could go read the documentation, but to basically look at a particular error and have the agent go source that information, you still need to have the expertise in terms of how to fix it. We'll get to automatic fixing, but for now, getting the information as quick as possible as to how to fix it is a nice step forward. Yeah.
To say the least. What else can you tell us about how this all comes together?
I think a key piece of this is back to kind of the Siemens EDA platform and this notion of a data lake.
Mm.
Now, Siemens itself, we're not going to have the capability to inform the world's designers in terms of how to make better designs. The data lake concept is the fact that you'll be able to put your designs in there, you'll be able to put your fixes in there, your documentation in there in a secure environment so that the more you use this and the more information you store about your designs, your design intent, and the rules you want to use, the information provided back to designers through the tools that I mentioned will just get better and better. And it's secure, it's your own. So as your capability using the Siemens EDA AI system gets more sophisticated, it's not shared with your competitors. The last thing a customer wants to do is inform an EDA company on how to do better designs that we can leverage somewhere else. We'd love to know. We would love for you to share all of your best practices and thoughts, but we know that that's not how the world works.
Right.
And the concept of the data lake means you can leverage this system. You can have your experts interact with that system. That knowledge can be transferred to, current, future employees, but it's held within your own company. Therefore, the integrity of your IP never leaves. And I think that's a key component in that the sophistication continues to grow, and yet an individual customer's IP integrity remains intact.
That's a really important point. So you've walked us through some pretty powerful tools, to say the least, that are available right now to designers. If you can, we'd love to hear more about where you think this is going next. What's coming up on the horizon vis-a-vis AI with regards to the Calibre suite or just in general at Siemens EDA?
Yeah, a lot of things on the plate. And anytime we talk to customers, they're asking, they'll take us in 5 or 6 different new directions. Most of what I talked about today is in the area of DRC. Within Calibre, naturally, we have LVS, we have electrical reliability checking, we have ways to enhance the design with metal fill shapes, with filler cells, etc. We will be extending these AI capabilities, primarily, as I mentioned, in productivity, in those other areas, going into LVS, going into PERC, leveraging them in metal fill technologies. And then the other thing that we're looking at, that customers are always asking about, is what are you going to do in the way of fixing? It's one thing to find the error, and it's another thing to tell an individual user how to fix it.
Mm-hmm.
The next step is to then fix it automatically and also then verify it to make sure that you're sign off ready. Our job is, as I mentioned at the onset, is to get you to sign off as fast as possible. And one is to do the checking, 2 is to help with the debug, and we will be looking at automatic fixing with implementation tools. And that will be really exciting because if we can take another step forward in terms of shortening the cycle time from initial design to final sign off and reduce the amount of fixing and debugging necessary, that gets those designs out the door even quicker.
Boy, yeah, that is really exciting stuff and music to the ears of probably every designer who's listening right now.
Right.
Really, really exciting stuff. Are there any specific resources we want to mention? Are they giving a white paper or anything like that away?
Yes, we have tech pubs, we have announcements, we have demo material across Vision AI and a number of the other capabilities that I mentioned.
Well, Carrie, we've covered a lot about the background of Siemens' embrace of AI, where the state of the science is today, as well as your thoughts about where it's going next. I cannot thank you enough for joining us today, sharing all of your insights and experience with our audience. Carrie, thank you so much for joining us.
Thank you, Eric. I had a great time. Appreciate it.
That brings another episode of EETimes Current to its end. Thank you for listening, and thanks again to our guest, Carrie Robertson. EETimes Current is available through the major podcast platforms, but if you get to us at our website at eetimes.com, you'll find a transcript along with direct links to the other stories we've mentioned and other resources. EETimes Current is produced by EETimes. It was engineered by Taylor Marvin at Coop Studios. I'm Eric Singer. Thanks for listening.